Right, yo. Okay, so this week has been, needless to say, pretty brutal in terms of the homework. So essentially, within a week's period, 7 days, we had to submit 4 homeworks, one being for each module that I'm taking this term. So I thought, okay, I've got 3 down, I've got 1 left. I've just submitted one of the other ones, and I thought, okay, before I even start the other one, at least I can reflect back and kind of let everyone know what's been going on with the modules I've been doing this term. Because I think I spoke about the ones I did last term. Did QFT, groups and reps. Oh, golly, we didn't like that one, no. And then also had general relativity 1. This term, slightly different. I have 4 modules, but the credits are like just slightly above where it was last term. That's nothing too nitty gritty to have to get into, but the way I'm going to break it down is I'm going to say which 4 modules I'm doing, give a little rough explanation as to which one, and then we'll just basically go from there. So I think the order that I'm going to do is I'm going to say which module it is first, based on basically how much I'm enjoying it, and also how much it's, it doesn't stop me waking up the next day and going, I'm not excited to wake up knowing that I have to do this, basically. So number 1 module I'm enjoying the most is Stat Mech and computer algorithms. So statistical mechanics and computer algorithms. I just call it algos. Simple. I'm not writing out the whole thing. I hate it. So basically, in this module, we start off looking at like Monte Carlo simulations and, just random sampling, direct sampling. You look at Markov chains, and all people that know the stats and probabilities know that all this stuff is pretty cool, pretty useful. So basically the way that works is it's just a homework module. We just need to submit homework, so you don't have to revise for an exam at the end of it, which is great, but that's not the reason I enjoy it. The reason I enjoy it is because for some reason I'm slowly getting into enjoying my coding ever so slightly more. I'm kind of like locking in on my brrr. Right, well, this thing just cut off, but yeah, essentially I'm just absolutely enjoying the coding. I've been doing like some, for people that know, HackerRank and League Code, whereas you basically just practice coding questions and you can work your way up in difficulty. It's got a vast array of stuff, and I've just been enjoying that type of thing. You can approximate a lot of things, and the thing that I probably enjoy the most about this module is that I can actually picture what is going on, whereas every other one of these modules, maybe GR to some extent, I can't picture what is going on. You just really have to just trust the maths, and at some point it becomes very, very painful. I'm sure you could probably find some physical intuition, but there's certain things which are just quite open areas of research, which is always a hard one to hear. You're like, oh, bro, you can't even explain this because we don't even understand what this is. So saying that, the thing that we lead on to next is, I would put second, just because I genuinely really like the lecture, Advanced Quantum Field Theory. However, this module is probably the most deteriorating to one's mental health module that I've ever done. Maybe with groups and reps up there. I think the issue with this one is that, like I said, you just can't picture a single thing. It's so abstract. So essentially, if when you do your undergrad in physics, some people will know, if I told you what a scalar was, you can look at a scalar, you can picture it. If I told you what a vector was, you can picture a vector. You can even be a bit more funky and go and do a whole vector space in 3 dimensions. Cool. Everyone can, basically go and do that. Like if you had like water spinning around like a sinkhole, you basically can just like put like little vectors and see how that all works, and you just see that it points around and it just governs the direction of flow, right? Like vector fields. The issue is when you get to particle physics, you have to describe these particles with these things called spinors. Like I said, spinors are not okay, I can just picture how this thing works. They're very, very weird things. So some, depending on the type of spin of the spinor, so people may have heard of a spin, you have like half integer, 0, 1, 3 halves, and then a 2. I think those are the only ones that we actually believe exist, or at least from our predicted theories, those are the only ones that should exist. We haven't seen a spin 2, which is a graviton, and spin 3/2, which is the gravitino, I believe, if I've been listening enough in lectures. But a spin half, what's weird is if I told you, if I spun around right now 360 degrees, I'd be facing the exact same direction. With these types of objects called spinners, a spin half, you would have to rotate it through 720 degrees to face back the same way. So it's kind of like if you did like a 360, it would be facing down, and then like the other 360 would come and be facing up. I think, like, if I can remember how to do with a mug. So the mug's like this, and then you have to kind of do something like that, and it comes out after you do like 720 degrees. That comes out, but you can't really picture these things. It's like people try, they do it online, but it just doesn't work. So unbelievable. Like there's no genuine, this is exactly what it is. Like, where's a vector? It's like, that's well defined. We know what a vector is. We know what it does perfectly. I guess we kind of know what spinners do, not me, because my maths, she do not be quite up to par like that, I'd like to believe. But yeah, so then you have AQFT. That's good. I really enjoy the lecturer. He's class. He's always good chat, and he's one of those lecturers that, what's quite nice is, I say my math's not up to par, but he very much, you ask him a question and he will try and give you the most physical reasoning as to why something's happening, rather than going, okay guys, well, if you look at the Lie algebra, if we go back to our axiomatics, what we can do is we can just redefine. It's like, bro, I'm just not going to follow you if you do that. I barely follow you now when you're doing the physical one. So now if you had to do the maths one, oh God, there'd be no hope for a man whatsoever. So yeah, he's great. I wish his lecture notes were a bit better, but that is besides the point. Great lecturer. And then what would I'd pick string theory next. Number 3, in the 3 slot, I'd go for string theory. String theory, people have probably heard of it. It's so basically, in the world of theoretical physics, we want to unify gravity and quantum field theory. They don't actually currently work in a quantum field theory, and actually, as far as I believe, gravity can't be put into what we know as current quantum field theories, so people need to make some other thing. String theory tries to solve that, and basically what string theory says is that every particle is essentially made up of like a one-dimensional string. Can be open, this would be an open one, or it could be a closed string, right? And basically the way that that vibrates basically will determine the particle's charge, its mass, its strangeness, all those properties that basically say this is that type of particle. And it is extremely mathematical. To some extent, there is a bit of physical intuition. I was chatting to my friend, and he gave me what this L operator was. I had no clue. I could understand the other stuff, but not being able to understand what this is, I'm just kind of just crunching down numbers for the homework, which I was like, oh, bro, I just don't even know what I'm putting in. I just know this L is represented by that, but what are those? And it's completely... It's a bit of a mess. Like, if you can't actually appreciate what it is physically, you don't really know what you're writing. And I think that's kind of a little bit partly on me, but yeah, it makes it very hard when it's just so mathematically rigorous. And I think string theory at this point isn't even like for physicists anymore. It's literally just a field that, as far as I'm aware, like, physicists, yes, do look at it, very like theoretical ones, but a lot of them really are just mathematicians that delve into like physics. And string theory's actually just created a bunch of new areas in like maths and physics, especially like different things like of topologies and manifolds, I believe. But yeah, I mean, it's 50 years old, and a big issue is that, I mean, the string theory that we're learning is the first level where you need 26 spatial dimensions. So yeah, it's pretty BS. I just don't trust it, but it's good fun. And then, lastly, not because I think it's because I just don't give this module enough time, which is general relativity. This is, I can actually probably picture it if I really was to try hard enough. Like, you can do it if you took away like one of the coordinates, right? You can have time, x and y. Just get rid of z, and you can actually just draw a graph up and a light cone, and you know, like x, y down here, time moving up, and you can just draw a light cone. That would be fine. I think I've just not probably given enough effort. I think GR1 wasn't even GR. We literally did no GR whatsoever. It was just pure mathematics. It was basically a class for tensor calculus, which is absolutely, if anyone's done a tensor, guys, like that's one huge issue on this course is there's everything is basically a tensor, and I have no prerequisite business of dealing with these tensors whatsoever. So I guess hopefully, if I was to recommend anything, if anyone wants to do a theoretical physics thing, bro, really understand your tensors. They're cheeky buggers. But yeah, GR1 was just pretty heavy on the maths. It was pretty nitty gritty. And then coming into GR2, I thought GR2 was a bit more self-contained, and you didn't have to do GR1. So you could do GR2, which some people did. Turns out, first lecture, I'm like, oh, bro, I'm going to breeze in. It's going to be a history lesson. Okay, cool. Okay, guys, so recalling everything from GR1, you have blah, 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 the Levi-Civita connection, this, blah, blah, blah. I was like, this is going to be a long term. So, yeah, GR2, I think when it comes to actually revising for General Relativity 1 and General Relativity 2, knowing that they're basically going to be written just a few days apart, probably, that will feel like just revising for one thing, which will be nice. But at the same time, right now, it's probably the module because it's the furthest exam away. I just don't really care as much for it right now. However, saying that, it is the last homework that I need to get in for this week by Friday, and I have yet to start it. Granted, it's midday through Wednesday, so what I got like 36 hours to get in. Easy. But yeah, those are all my modules for this term, and it's pretty nifty. But I'm gonna start cracking on with GR2 and some gravitational waves. So yeah, catch you later.